Hey folks, this is Shetz, and sorry about Thursday's answer key, but I'll have that corrected. I know you could not put the word PI in for pie, but hopefully for Monday, I'll have it all straightened out. What I'd like you to do is watch this video. I'll keep it very short, but I'll tell you, this is a foolproof way of figuring out reference angles in radians. And just understand that radians is just like speaking a different language. Pretend that we're living in France, so always speak the radian language. We're not going to deal with degrees anymore. Okay, so I want you to watch this video before Monday. And as you know, half of this circle is 180 degrees or pi radians. And if we do half of what we just did, then you are going to get 1 pi over 2 is straight up. Now, all it is a matter of counting. 1 pi over 2, 2 pi over 2, which equals pi, 3 pi over 2, and then 4 pi over 2. There you go. All I did was count every 90 degrees. Okay, so let's do a problem using this board. How about 5 pi over 4? Well, I need to break up this top into quarters. 1, 2, 3, 4. 4 sections to pi. And let me grab my pi back out there. There we go. So all I have to do right now is count. So watch the bouncing ball. Here's 1 pi over 4, 2 pi over 4 reduces to pi over 2, 3 pi over 4, 4 pi over 4. Hey, this must be 5 pi over 4 right there. Now, anything in the second, I better put that back. Anything in the second and third quadrant, we got to get back to pi. Well, this measure getting back here is just 1 pi over 4. So that is our reference angle. Theta prime, the reference angle, will simply be just a pi over 4. And I know we're going clockwise, but let me remind you, reference angles are always positive and they're between 0 and pi over 2 radians. They're less than 90 degrees. A-okay? Now, let's go on to this problem. And here's our problem, 17 pi over 12. Well, the very first thing I always do is we know this is pi, and whatever your denominator is, your numerator is going to be the same. 12 over 12, pi reduces to pi. Well, wait a second. What's half of 12? Well, that would be 6. 6, 12. Guess what this is down here? 18. We're counting by sixes. 6 and 12 is 18. Plus another 6 would be 24. Great. So what I did was I changed up. I wanted 19 pi over 12. So 6, 12, 18. Guess what? Down here, whoops, let me just group them together. There we go. So down here, just past the 18, is going to be 19 pi over 12. Like that. I don't have to be exact. And notice, this is counterclockwise in standard position all the way around to here happens to be 19 pi over 12. And any angle in the first or fourth, we have to get back to this 2 pi right here. Well, 19 plus what's going to give us 24? That's right, folks. Our reference angle is 5 pi over 12. 19 plus 5 gets us back to the 0 or 2 pi, and we need 5 more pi over 12. So again, I'm back. That was my honey bunch. So I don't care what this denominator is, the numerator is going to be the same. Then you take half of that and you put it there. This 6 and 12 gives you 18. That's going to be straight down. And then another 6 would complete the full circle. Therefore, we wanted 19 pi over 12. It's just going to be just over the 18. And that means the reference angle, this is our terminal side. We have to get back to the x-axis. So we actually need this much here. And this much here is in orange, 5 pi over 12. So I do that every time before I even start. I'll label, 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 and label anytime before I start. Let me do one more quick problem with you. And here we have 11 pi over 7. Well, guess what, folks? I know that this is 7 pi over 7. Half of 7 is 3.5. This is the only time I will ever allow you to put a decimal in a fraction is when you're doing these type of problems. 3.5 plus 7 down here must be 10.5 pi over 7 radians. And another 3.5 added to 10.5, this would be 14 pi over 7. Now guess what, folks? We want 11 pi. Well, there's 10. So 11 is going to be close like that. That means all the way around the circle, that should have been a blue color because that was our original problem. All the way around is 11 pi over 7. We got to get the 14. So therefore, I need theta prime. I need 3 more pi over 7. That is the reference angle. There you go, folks. And we are going to do one more, folks. We'll do a hard one again. Here's negative 13 pi over 11. Now just remember, negatives, we have to start here and go clockwise. So, again, let's set up our chart. This is negative 11 pi over 11. Whatever that denominator is, the numerator is. Since we're going clockwise, half of 11, negative 5.5, straight down. 5.5 plus 11 is 16.5. That's straight up negative. And another 5.5 would end up at 22 pi over 11 negative. Now we need negative 13, so that's going to be just a little more than negative 11. I start here, I go all the way around here. There's negative 11 plus 2 more ticks. I guess something like that. You don't have to be exact. And again, like we did the first day of writing angles, I draw my arrow. Remember, I walked around the room and told you to do all that. And there you go, folks. So we need to, this is my terminal side. Now I got to get back to the x-axis. And if I'm at 13, I got to get back to 11, which is 2. And therefore, our reference angle, theta prime, our reference angle is 2 pi over 11. Reference angles are always positive. And notice that is between 0 and pi over 2. There you go, folks. I hope you have a better understanding. Sorry this video was long, but I'm telling you, this is freaking easy to do. You always label this first, and because it's negatives, half of this is this. This plus this gives you that. And then another 5.5 gives me 22. So there you go, folks. Hope you enjoyed it. And you have a great day. Please watch this video before Monday.